Hello everyone, we are from Team 1, Section 17 from first year at Iit Kgp and we have made an Arduino controlled door lock system for a DIY assignment 4. The team members are Ritik Raj, Rijoy Das, Arun Chakravarti and I, Saharsh Agrawal. So, password protected door locks are already very common in electronic safes and doors with restricted access, but they are quite expensive as they use a large number of components and their circuit is really complicated. We have tried to make a reasonably secure model which is much cheaper and it uses a single lock and an Arduino board. So we have made this cheaper alternative to the password protected door lock using Arduino and solenoid lock with a budget of less than 1500. These locks can also be used in making safes. So this is a final circuit. The one we see on the outside, this part lies on the outside of the room or the safe, and these parts lie on the inside of the room or the safe. So we have the 4x4 keypad, the 16x2 LCD which is connected to the I2C module. We have the 12 volt battery which will be replaced by 12 volt DC adapter in the real project. We have the Arduino Uno board. We have 12 volt solenoid lock. We have a single channel relay, a push button, a few resistors, a buzzer, and to connect them all we have the breadboard. And of course we have the conducting wires. This is a final circuit schematic. Now this is the code for the Arduino Uno. Here we have initialized the variables for the keypad, for the LCD and for the code logic. Here we have run this setup function where the LCD is initialized and the pin modes are set. Now we have a function called clear all which will clear the LCD and print enter password. We have the open door function which opens the doors for 5 seconds and then closes it again. Now here we write the code for the loop. It continuously checks for input from the keypad. If the user inputs invalid keys, it will show invalid, or else it will keep on adding the characters in the LCD. Once the user presses the enter button, the hash button, it will check if the password matches. If it matches, the open door function is run, or else it shows incorrect password. Now we also have the code for the 30-second protection over here. So these are the components that were required and their cost that was incurred. So the total budget is 1410 for the components and 70 for the soldering and the resoldering. So that is almost 1500. The softwares required were Tinkercad to design the circuit and the wiring, simulate the code and get the code, Arduino IDE to load the code in the Arduino Uno and run it, and FreeCAD to design the CAD model of the mechanical parts of the system and the door. Some pictures of our model from various angles. So here we have the push button on the side which will actually be on the below part, but for simplicity we have kept it on the side for this model. Here we have the LCD and the keypad on the front, and the inner working components are inside the box. It is powered by the 12 volt DC adapter as we can see. So this is inside our lock system, the breadboard, the speaker, the relay, the solenoid lock, the Arduino Uno, the keypad, the LCD and the 12 volt DC adapter. So this is a small demonstration video for how our project works.
So if we enter the correct password, which is 5637, we can also go back using this. So if you enter the correct password, it says door open, the lock has gone inside and the relay light is also glowing. Now the door closes after 5 seconds and the lock has come out again. One can also open the lock using this button over here from the inside, so he doesn't have to enter the password. So doing this will again open the lock for 5 seconds. So door opened, lock has gone inside, and after 5 seconds it will close again. If we enter the password 3 times incorrectly, so this is 1, this is 2 and this is 3. So if we do this, it says enter password again in 30 seconds. One has to wait before you can enter. So we can see the keys are not working anymore. In the meanwhile, even if the door is locked from the outside, we can still open it from this side. So see, the door has opened again and the wrong count again resets itself. So door has closed. If we enter a key which is invalid, like this, it shows invalid key. So these 4 are invalid keys, this is for enter, these are for the numbers, and this is for backspace.
Now let us have a look at what else could have been achieved for higher security and given a higher budget. So we could have used an RFID sensor for authorized people to enter just by sliding the card and without entering the pin. We could have used a fingerprint sensor to do the same, and this will also allow for user identification. We could have put a security camera which will record who has entered the wrong password, and we could have also set up a mobile notification system which will send an SMS with the photo of the person who's entering a wrong password. We can also allow for change of password by the admin to strengthen security. So this is the work division for team 1.